Okay, we're going to continue. Looks like some of you are going to need a rest. We're going to continue with the irrigation scheduling. The concept, and we have got, if you look at the kind of irrigation system we have here, we have mostly our system of irrigation is surface irrigation in the valley. And if we do this right, it could be quite efficient. You know, the common notion is that the surface irrigation is inefficient. It doesn't have to be. We can really inject up the efficiency in system irrigation very quickly. So I'm going to talk about how we can manage our water better, because historically we have had no limitation on how much you can pump. But now we're going to have a cap of 4.5, and we need to try to manage it a lot better than we did in the past. So I'll talk about how we can take the maximum use out of that water cap. So when we apply water to a field, the part of it goes to evapotranspiration, to consumptive use of the crop, and part of it goes to groundwater, and some of it may run off. In our area, we don't really have any runoff. In our system, we have closed basin systems here, so we don't really have a problem with runoff. But we lose, our study shows we lose about, the average, about 38% of our water to below surface, basically. And if you, 38%, our average efficiency. Pecan is about 62% efficient. Alfalfa is about 59% efficient, and cotton is about 66% or so. So we lose quite a bit of the water to groundwater. Part of it is a combination of design. So now, from now on, once the water goes below the surface, it's not our water anymore, it's gone. So how can we deal with that problem? So the way to deal with this is the way to, so the beneficial use, at least from there are different definitions of beneficial use. From education point of view, that's a different thing. But from individual farmers' point of view, this is your beneficial use, the rest is lost. So depending on what you're looking, so if you're a farmer, your interest is different than if you are the state. So there are different objectives there. From the state point of view, whatever is lost to the groundwater is not lost because it's part of the pool of the water they manage. But from your farm point of view, individual farms, this is your loss. So the way to minimize that loss is there are design factors which you can use, and our people from the NRCS are here. Christy is here to talk about how you can increase your efficiency by changing your design characteristics. Some of the most common approaches for increasing the efficiency through design is land leveling and reducing length of the run. You know, a shorter run will give you the efficiency. Modifying the soil type, discharge rate. The more flow rate you have, the more efficiently you can irrigate, especially if you're using pump. You know, one of the things we have been doing is filling up the irrigation canal if you can, and then using, once it's filled up, so you're running your pump for a couple of hours, fill up your ditch, and then irrigate with that. You can get it end of faster and more efficiently. So an irrigation system, you could, there are flood irrigation, as I said, right now our systems are about 65% or so efficient. With a sprinkler system, you can go up to 75, probably 80%. Drip system, you can go 90%, but we don't have the luxury of doing that in this valley because, first of all, our crops are not prone to drip irrigation. We are looking at alfalfa. You can use drip irrigation alfalfa, and right now our alfalfa crop we produce about 7 tons per acre in the average in the valley. With drip irrigation of alfalfa, you can go to 10, 11 tons per acre. But economically, that doesn't work out very well, at least and besides, not only that, we have a problem with the sediment load in the irrigation water. It's not easy to run that EBID water through a drip line. It will plug up, especially drip tapes. So technically, we have got limitation. So a sprinkler system, kind of the same way. We have got limitation on how far we can. In some areas you can do that, and you have to do that. But the majority of the cases, you can do as good of a job with flood irrigation as you could do with more advanced irrigation technique. What I'm going to talk about today, what I'm going to focus on is management techniques. And management means how would you schedule irrigation to maximize your return? How much water you put in and when? So and in flood irrigation again, by the time we get the water at the end of the field, we put in 6-inch to 8-inch, maybe sometimes 10-inch. So we can't really control that very much. We can do it through the design, but we can't do it through the operation. So, but what we really can control is when. If we need to figure out the time of irrigation, if we can figure out, when you irrigate today, what is the next irrigation going to be? When is it going to be? And if we can do that on time, or do it so that we are very close to the optimum time, then we will have good yield and we won't lose the water. The water used, the plants basically use, most of our water that we put in the plant is used for evapotranspiration. And that's a function of the solar energy, how much energy we get, And plants typically use about 99% of the water a plant uses, they use it for cooling. It's like the plants are basically evaporative coolers, natural evaporative coolers. They use it for cooling themselves. They're not using it for growth. The rest, only about a small, less than 1% is used for the growth, for the photosynthesis process. But the majority of it is just a cooling process. So by that, it basically means if you have, as we go through the season during June in our area, we have the highest water consumption. And then June and July basically, and then it drops off and goes down a little bit. So there are different ways of estimating, figuring out how much water you need to, how much water your crop is using. So your soil basically is a reservoir. It holds so much water once you irrigate. And you want to use that water before you irrigate again. Because if you don't, then when you irrigate again, you will spill over and will go back to groundwater. So the first thing we need to do is estimate how much water the plant crop is using. And there are different ways of doing that. And the most common and traditional way of doing this is this equation basically, which is they take a crop coefficient and multiply by what we call a reference ET. This is the atmospheric, this shows the atmospheric potential. So if it's hot, if you have, the hotter the air gets, so the more windier situation you have, this one goes up. So this shows the atmospheric potential, this shows the crop potential. So they combine those two and you calculate how much water you use. And I'm going to show you some simple ways of doing that because you don't have to necessarily know these values to do that. So I'm going to show you some simple ways and I'm going to show you some more complex ways of you can do that. So another way we can figure out how much water is being used. We don't necessarily, it's through remote sensing. And remote sensing has not come to a point we can actually do this on a real-time basis. And that cannot be done at the individual level. We can do it, university is doing it in the large scale. So we know, but right now we have the information, like every farm in the valley, we know how much water they used, like 2010. But now we're working for 2011. So these are they consider the diversity of water use. Part of it is due to crop, part of it is due to management. But this is not something you can use every day in your farm. I'll talk to you about, what I want to talk about is how do you do it, if you have mature, well-grown, basically mature pecan tree, that basically mature pecan tree is referred to a pecan tree which is 75 to 80% ground cover. It's basically grown. How would you estimate how much water you need for that crop? How much water that crop is using? That's the first thing we need to do is figure out how much it's using. There's a simple way to, I had a slide here I wanted to show you. Okay, before I do that, let me show this. The way we do this is we figure out our soil basically is a reservoir. The water, when we irrigate the crop, we fill up the soil and some of it spills over and goes to groundwater. After the irrigation, about 1 to 2 days after irrigation, depending on your soil basically comes to what we call a field capacity. That means the extra water drains out and you have a field capacity. It's like a sponge where you put in the water and you lift it up, it drains out and then it stops draining. That water which is staying in the sponge by capillary force, that's the field capacity. That's how much water the soil holds. In practice, you can only use about between 1/8 to 1/4 of that water before you have to irrigate again. So if you go too far, you will hurt your crop, your production. And if you don't get to that point and irrigate earlier, your water will spill over and is lost. And 1/8 is for shallow root crops like onions, for example, or lettuce and so forth. And for deep root crops like cotton and alfalfa and basically corn, crop like cotton, alfalfa, and corn and so forth. This is and pecan is 1/4, 25%. That's the rule of thumb. Very simple system. So we go back to this. How do we estimate how much water a pecan uses? So once we figure out how much water the soil can hold and how much we can use up, how much that water can be used before the next irrigation, once we have that number, then we can go back and calculate the water used by the crop, and then we can figure out when is the next irrigation. There's a simple way to estimate water use of a pecan, mature pecan. And this is an average number, and we are looking at averages here. Some years may be harder and you have to adjust that, but in the absence of having anything else, this is a good way to do this. So what you do, these are what we call crop coefficient of a mature pecan orchard. And then this is the average atmospheric potential of our area. So these numbers, these yellow numbers, is what you want to look at. So for the month of March, the pecans here normally start germinate or buds out basically at about end of March around here, end of March, beginning of April. But I've put the March water use in there because even though the pecan appears to be dormant, it still uses water. So for March we use about 2.1 inches of water. That's how much the crop uses. And it goes toward April is about 4.5 inch, 7.8 inch, and June is about 9.6, and July is about 8.9. We have got more cloudiness in July, so the water is dropped slightly. And then August it goes to 9.6. The pecan tends to increase its water use potential as it starts building up the nuts. Basically, as the nuts form, it jumps up in water consumption, and that's a critical stage. And some people argue that at this stage we shouldn't wait for that 1 quarter depletion. We should go to in a state of 25% depletion. We should go to 20% because the crop becomes very sensitive to moisture stress at that point. And then October and November, we normally don't irrigate in November, but I've put that number in there. Just in some years, our growing season extends to the end of November. So these are the numbers we're looking at. You can just go straight and go ahead and use this number straight out, basically. If you have a younger pecan, which doesn't cover the entire field, then there is a simple equation which we have developed here, and there's a paper on that which show that this. All you need to know is this: you take the number for the mature pecan and you multiply it by 0.6 times the fractional cover plus another number. So, and I will give you an example. Let's say your fractional cover is 40%. That basically means at mid-noon your crop covers your ground at 40% of the ground is covered. So it is young pecan, it's not grown yet. In that case, from the previous table, your water use for the month of July is 8.9 inches. You plug in this equation, 8.9 inch times 0.6 times 40% plus 0.48, your water use is 6.4 inches. This comes out, by this method, we can come to about 90-95% of the water use, very close estimate of water use, and you can't really do any better in practice either. So this gives us a simple tool for scheduling, for figuring out what is the next irrigation date, what's going to be the next one. And alfalfa is even easier. What we figured out in the alfalfa is that, and if you, because of alfalfa because in alfalfa we have a cutting cycle. It goes through cutting cycles. So we have about 6 to 7 cutting cycles a year here. And so, alfalfa starts in March, early March, and sometime end of February. So the consumptive use, the practical consumptive use coefficient for it is 0.8. So you take that and multiply by the atmospheric values, and you end up with 4.3 inch requirement for the month for the first cut, basically, for the month, not for the first cut, for the month of March, 6 for the month of April, and 7.2 May, and you just go through this. So these are the average coefficient for the different months, the growing season for alfalfa. So for the first cycle, for the first cut, these are your requirements, and the next cut is going to be about 7 inches, and the next cut is about 7.6, and just go through that. Okay. How often we should irrigate then to figure out the next date of irrigation? We have to look at our soil and root depth and the ET. So, and I talked about this one. So you have to look at how deep your soil is going to be, and how deep your root depth is, and what kind of soil you have. The combination of the two will tell you how much capacity you have in the soil, how much fill capacity you have, and then how much water you can store, how much usable water you can have on that soil. A typical, for example, pecan root growth is about 3 feet to 4 feet. In sandier soil is more like 4 feet. In clay soil is like 3 feet. And so you can use that number, and you can look at your soil, and you can figure out what is the storage capacity and how much water you can store on that soil, on that root zone before you have to irrigate again. This is a table of different crops. For example, alfalfa can go from 3 feet to 10 feet potentially, but in practice, you're scheduling, you don't want to go more than 4 feet. So you're looking at 3 to 4 feet for alfalfa. Cotton is about 3 to 4 feet, and pecan is about 3 to 4 feet. Sandy soil I will use 4 feet, and clay soil I will use 3 feet. So, and some of the other crops like chili is only 2 feet. So this is your depth of the soil you can work with. And then once you figure that out, you go out in there, and there are NRCS soil maps you can use, but they're very rough. They're not very accurate. But they're the best you can do if you want to go out and look at the maps. But you can also do your own measurement, and this is a lot more accurate if you can. You can get better information in your own field if you can do this your own test. And all you do is take an auger, go down, let's say 3 feet, take a soil sample, and you can put the soil out there in the sun, let it dry up, and you weigh it before you put it in the sun. And what you do is you have to go that day after irrigation when the soil is wet. You take that sample, you weigh it, and you put it in the sun and weigh it again, and find out what % of that soil was water. Once you figure it out, you multiply it by a rough number, average number of 1.2, multiply it by root depth, then you have got your field capacity. So let me give you an example. Let's see that you have a alfalfa, you're looking at 4 feet, and soil moisture measurement, you have measured 40% of soil moisture after irrigation. You put in this equation, 1.2 times 40% times 4 feet, it gives you 1.92 feet, 23 inches. That means your soil is holding, field capacity is holding 23 inches. Using 1/4 of that, you're dealing with 5.8 inches. That's how much your soil can hold. And once you have that number, you go back to the table and you say, okay, 5.8 inches. So if you irrigate 1st of March, you can carry it through the 1st week of April. And you irrigate again, and it will carry you through the 1st of May. So you can actually follow this requirement versus how much your soil holds, and you can manage your water.
Can you flash the formula again?
Which one?
The field content.
Here. Oh, this one? Yeah. Okay. I'm sorry, before that. I'm sorry, hold on. This one, right? Which one are you looking at? This formula? Okay. I'm going to make this available. I'll put this in a web page on a server and send you the link so you can download it. And if you don't get it, send me an email. I'll send it to you. Okay. So these are some simple tools I've developed, so you can go out there and do your management, because it's just really, if you want to do this, you don't want to go to school for 4 years and figure out to do this. You want to do this quickly. And that can be done very effectively in our area. And if you have any question, go to NRCS, they can help you. They know about these things, So that's how you do it. This is the NRA. They used to have a manual or report which you had all this information, and there are maps. You can find your farm in the map, and you look at it and say, okay, my farm has soil, and this soil has 0.15 to 0.2% available water, and you can multiply by the depth of the root. You know what your usable water is, and you can go from there if you want. As I said, my experience has been this: the maps are very rough. They've done, and so they are not detailed. If you want detailed information about your field, you have to do it yourself. And we also have, in the majority of the cases, we have layered soil, and you have to watch it because there is a difference between if you have uniform clay versus if you have 6 inches of clay underlain by sandy or medium soil, the characteristic changes by that layering thing. So you have to measure that. So, but you can also go to the website here. This is a website that NRCS has, and you can pull your map, your soil map out, and you can look at what kind of a soil map you have. Rainfall, we don't have much rain around here, but we get about 4 inches in normal year during the monsoon season. So, and during the year we have an average of 8 inches of rain. So it's a good thing to use your rain. So when we have a rain, a rule of thumb is 50% of the rain can be counted as effective rain. So if you have an inch of rain and your water use is like 0.2 inches, then you say, okay, half of it that is useful, so I can probably delay my irrigation 2 to 3 days. So you can use that to delay your irrigation. So that's how we use the rainfall information. And that's it. If you have any question, again, you can contact us, and I will send you this PowerPoint. I've got to send it to you. So there is, of course, this was for pecan and alfalfa, which are predominant crops around here. It gets a little more complicated with cotton and chili because they grow. It takes a while for them to grow to full potential. So we have during the lunchtime, my student will show. We have developed a program where you can take an iPad and you can send a message to a server and say, "This is my farm location." You basically put in your GPS coordinates of your farm and tell the program what crop you are growing and when was the last time you irrigated. And immediately it will come back and say, your next irrigation is this date. So, very nice. So, you have to get yourself an iPad first. And that's the excuse to to tell your wife, I need an iPad. So go at lunchtime, get one of my students, he will show you how that thing works. It's very neat. We're going to, and we can link everybody to that database if you want to. So, and that's it. Any question? We have time for question. Good. 5 minutes. So. No question. Okay.
Could you put it back to the home page once you write it down?
Which one? Oh, web page. Okay. Yeah.
One more back. One more. One more. That's it. That's it.
Yeah. Okay. Yeah.
Google web soil survey.
Yeah. You just go. Yeah. Web soil survey. It will come up, right? That's a long link, huh?
Yeah.
That's it.
When I'm in a hurry, I Google it. I mean,
Yeah, this is really neat. I'm so, this used to be so hard because you couldn't find your map when you find them in the map. It's murder. This one, you just put your GPS coordinate, you're there, it's magic. And
There's the map.
yeah, they print the map. You can download your map and it tells you what soil you have, what characteristic your soil has. It's very nice. But I found out, that you have to do, if you want detailed analysis, you have to go do it yourself in your farm. Yeah.
I don't remember what the scale
Yeah,
between those apps.
yeah, but it gives you good information. Immediately you can tell where you are, roughly. It tells you, in fact, you don't even need the formula because the this web page gives you the that 1/4 or gives you, I think it's 1/4. You have to kind of adjust that if you are looking at different crops. So that number is, I'm sorry, it gives you field capacity, right? It gives you field capacity, so you can decide what fraction. You don't have to go take your sample if you need to, at least in the beginning. So it will give you the field capacity value, so from there you can go calculate your available water. Okay. Thank you. So next person is going to be.
The preceding was a production of New Mexico State University. The views and opinions in this program are those of the author and do not necessarily represent the views and opinions of the NMSU Board of Regents.